Welcome. I am going to solve an important question where people who have confusion about this type of loading and trapezoidal loading, complete clarification will be given. So what you do is, this question you go through repeatedly till you master it. Question will be by word, not words now. This time sketch class. For the given, I think 16 is correct, I think most probably. I don't remember. Most probably correct. Okay. Otherwise, I will change the next question. For the beam shown in figure, find the vertical reactions at the support. Okay. See, I already got the reactions here because I am solving it total 4 times. All the 4 times answer will tally. Therefore, just for safer side, I do not want any calculation mistake. So I checked in the beginning only. Okay. Now, usual, let VAV be upward as usual. Okay. Now, mark here. See, this is 2 meter. This is 8 meter. This is 2.5. This is 4.5. 4.5 plus 2.5 is total 7. 8 plus 2 is 10. This is 10. This is 7. Total 17. Total 20. So this gap will become 3 if you want the gap. Okay, now, option 1, class. This is uniformly varying load represented by a triangle in general. See, you are very happy if it is isosceles triangle. Why? Directly resultant load will come to center. Or right angle triangle. Again you are happy. Either 1/3 or 2/3. But this type of triangle, so be careful. I will tell here once again. See, if this is A, this is B, loaded length is L0. See, our question, L0 equal to 8. A is 4.8, B is 3.2. Total load will pass, resultant will pass on that side where length is more here. So little this side, but does not matter. So now whether it passes this side or that side, suppose this is smaller, this is bigger, it will go that side. But still, distance formula is same. From left end, from this end, see, not from A. See, now it is from C because earlier question solved, this point was here. Now, there is a gap here. Only for C to E, resultant will pass at total length L0, that is 8, plus this cut length 4.8 divided by 3. See here, see, this will become from here to line of action of resultant. So if I mark the resultant here, light line, see, resultant here for the complete triangle, see, full triangle. It will be total length 8 plus 4.8 divided by 3. If I want from that side, from here if I want, it is total length is 8 plus 3.2 divided by 3. If you take moment about A, you require only this distance, but there is a reason for giving. Or now, come to trapezium. Consider the full trapezoidal load, full. Resultant will come here, the total load. See, here, this total load. Total load equal to area. Area equal to, if this is W1, this is W2, loaded length is L0, area equal to W1 plus W2 by 2 into L0. And centroid will be at, from here, where that load is acting, W1 plus twice of W2, see, this side plus twice of that side, that is from F and G, divided by W1 plus W2 into L0 by 3. So this is a formula here, this is a formula here. If I substitute here, this will be W1 is 54, 54 plus twice of 32 divided by 54 plus 32 into 4.5 divided by 3. Whereas if I substitute from here, if you want, it is W2, 32 plus twice of 54 divided by 32 plus 54 into 4.5 divided by 3. And if you want total load area, it is 54 plus 32 divided by 2 multiplied by 4.5. If this much information is given, now I am going to rub this one. This is actually told not once nor twice. Many times it is told. Still I thought Better explain once again. Okay, I'll remove everything now. Make outside note. Now, solution 1, we will consider full triangle, both and one single triangle and trapezium. Okay, start. This is a lengthy question. Today's class only one question. Sigma m about A equal to 0. Take clockwise positive. Okay, start. Moment about A. Minus VB into 20. VB into 20 plus this total load, just now explained, half into 8 into 45, half into 8 into 45 is the total load multiplied by, from here to this line of action of total load is 2 meter outside plus another from here to here, just now I explained, 8 plus 4.8, 8 plus 4.8 divided by 3, just now explained, okay. Plus this total load, 54 plus 32 divided by 2 into how much? 4.5 is the total load multiplied by, from here to line of action is 2 plus 8, 10. 10 plus 3 is 13. 13 plus, from here, moment about A you are taking. When you take moment about A, 2 plus 8, 10 plus 3, 13, 13, and then this distance is 54 plus twice of 32 divided by 54 plus 32 into 4.5 into 4.5 by 3 equal to 0. You will get the value of VB. VB will come, I already got it, plus 202.0875 kilonewton. I write a full number. Then make sigma V0. Take upward positive. Plus VA plus VB minus this total load, only load, half into 8 into 45, again minus this total load, 54 plus 32 divided by 2 into 4.5, 4.5 equal to 0. Now, substitute for VB, whatever you got there, substitute that one. Therefore, you get the value of VA plus 171.4125. 4125 kilonewton over. Then do one thing, come back here and make entry here. Once again put the sketch. Do not write in the original sketch. This sketch, now write it. Right here, VB equal to 202.0875 kilonewton, and here VA equal to 171.4125 kilonewton. Not 875, not 8, 4, 8, 1, 2, 7, 8, 9, 5, 4, 8. Okay, correct. Over. This will give solution 1. Now, I'll do one thing now. I'll tell some important concept, but I'll pause for 1 minute. Make a note. This is only for understanding purpose. We found VA, VB considering full triangle and full trapezium. We applied sigma m about A0, then we applied sigma B0. Make a note. Now, for only understanding purpose, we will interchange. What we will do is, same thing, option 1 only, we will solve once again. Once again we will solve. But this time, when you take moment, first you will take moment about B, not A, moment about B you will take. Purpose is, sometime in cantilever solve, you have to, when the fixed end is right side, you should know how to take moment about B. Okay. Then this is gone. I'll change it now. See. Now that one leave it now. One more solution. Take moment about B. Remember. B. Start. Plus VA into, it is plus VA into 20 minus, see, minus moment of this load. Half into 8 into 45. Half into 8 into 45 is the total load, multiplied by moment about B is 2.5 plus 4.5, that is 7. 7 plus 3 is 10. 10 plus from here to this load, this line of action is 8 plus 3.2. Is all explained for you. 3.2 divided by 3, that is this distance. Again minus y anticlockwise, moment of this load. 54 plus 32 divided by 2 into 4.5 is the total load. Total load here, multiplied by moment about B, this total load is 2.5, little space I want. Okay, I want little space. 10 plus, how much it is? 10 plus 8 plus 3.2 divided by 3, okay, minus 54 plus 32 divided by 2 into 4.5 is the total load, multiplied by moment about B 2.5 plus, see, moment about this point, so up to here 2.5 plus this distance is from here 32 plus twice of 54 divided by 32 plus 54 into 4.5 divided by 3 equal to 0. Let me check the camera once, because important step should not go out of the board. Okay, no. Okay, no problem. Equal to 0. What will happen? Instead of VB, you will get VA first now. See, last time, see, if you are doing this way, don't do the last way. You will get VA first. 171.4125 kilonewton. VA over. Now, sigma V0, same thing. VA plus VB minus this load, and substitute for VA value, you will get VB value now. VB will come 202 plus 202.0875 kilonewton over. See there, same answer what you got. This is your option 1. Actually what you have done is, you take moment about any one point, you get other reaction, then sigma V0, you get the remaining reaction. We first solved by taking moment about left end. We got right reaction. Sigma V0, we got left reaction. Then alternately, you can write here, once again means or either alternately, we first took moment about B. We got VA first. Sigma V0, we got VB. This is to understand. You should know how to take moment about left side, right side. See now, in earlier question solve, the points were touching the, see, your supports were here. Because this load was for full span. Now gap is there. So plenty of gaps are there. So this is a master question for understanding how to find reactions for uniformly varying load represented by a general triangle. See, when general triangle is clear, isosceles triangle or right angle triangle becomes more easier. Okay, this is your option 1. Now go to option 2. Be careful now. Option 2. Option 2, class, something I will dictate. Okay, I will first dictate, then I will prepare the sketch. See. Some dictation, right here. First, see the question here. Uniformly varying load represented by a triangle where one is 4.8, other is 3.2. Some people will have difficulty for centroid. They get confusion. Sir, it is not right angle triangle, sir. Yes. Then how to locate centroid? Then what you are doing all these days, 30, 40 times I explained. Okay, but still people are there who don't like it. Okay, then what you will do is make a note this triangle, see this point is there, C to C, I'll take the point as C here, this point is E, this point I will take F, and this point I will take G, this point I will take D. Last time you took C to E single load. Now do one thing, C to D and D to E take separate loading. Two right angle triangle. Okay, taken care. Make a note. What you will do is no sketch required. When you write the sketch here, CD and DE, those portion load separately, and uniformly varying load. See, it is like this. Here 32, here 54. What we will do is, we will divide it into, this is a point F, this is a point G, equal to, see, one rectangle of 32, one triangle of this side, you write 32 here only later, 54 minus 32, 32, that is 22. 22 correct? Yes, 22 correct. 22. So therefore, in place of trapezium, you will have a rectangle that is UDL of 32 kN per meter and one triangle represented by right angle triangle 0 here to 22. Now I will put one more sketch here and solve it. Okay. I wrote a neat sketch now. See, everything explained for you. This triangle, see, red color, hash, dot, dot, dot. Here, separation you can see. Now see, this load is right angle triangle, right angle triangle. This is right angle triangle and rectangle. Actually, so many people, they want this way. Just to understand for you, from here to here is 2 by 3. This is 1 by 3 for this triangle. For this triangle, here to here is 1 by 3. This is 2 by 3. This is center. This is from here 2 by 3. This is 1 by 3. Sufficient. Now further I should not explain. I will write here. Again, class. I told everything. Option 2, sigma m about A0. Take clockwise positive. Okay, start. Minus VB. This is usual. Oh, I forgot to write that length here. Full length, I forgot to write. Okay, I'll write it. Nothing to be left out. So that there is no confusion. Okay. Full length is 20 meter. Forgot to write. 20 meter. Okay. I'll start from here. This space I'll use it. Sigma, little more space required. I'll start from here. Sigma m about A equal to 0. Take clockwise positive. Start. Moment about A, finger should be at A, VB into 20. So, anti-clockwise. Minus VB. See, I am still putting that dot into 20. This shows moment into. Now, all are clockwise, so plus. This load, half into 4.8 into 45 is the uniformly varying load represented by a triangle for this side multiplied by 2 meter. See, finger is at A. 2 plus this distance is 2 by 3 of 4.8. If it is still not clear, I will tell better not study subject. Okay, then once again plus moment of this load. Half into 3. See, my finger is still at A. 3.2 into 45. I told you this will give you the load. Load into from A to line of action. 2 plus 4.8 into 6.8 plus this distance is 1/3 of 3.2. Still not over. Plus clockwise. Moment of this rectangular, not rectangle, UDL, 32 kN per meter for 5.5 meter, easiest in the world. 32 into 4.5 is the total load multiplied by, see here, 2 plus 8, 10. 10 plus 3 is 13. Moment about A, 13 plus from here to center of the load is 4.5 by 2 plus once again moment of this load. Half into, see, this is the load, half into 4.5 into 22 is the total load multiplied by 2 plus 8, 10, 10 plus 3, 13, 13, actually 3 meters, it is 3 meter up to here, okay, 3 meter, little shifted, 13 plus another, this distance is 1 by 3 of 4.5 equal to 0, calculate, you will get the value of VB. I will once again calculate for your sake. Actually, I need not calculate. I can write the answer 202.0875. But in case any calculation mistake is there, print mistake is there, I can check it now. Okay. Half into 4.8 into 45 into bracket 2 plus 2 by 3 of 4.8 plus half into 3.2 into 45 into bracket 6.8 plus 1 by 3 of 3.2 over plus 32 into 4.5 into 13 plus 4.5 divided by 2 plus half into 4.5 into 22 into 13 plus 1 by 3 of 4.5 divided by 20. So it's giving some nonsense answer. I don't know what happened. 1 minute. Half into 4.8 into 45 into bracket 2 plus 2 by 3 of 4.8 plus half into 3.2 into 45 into bracket 6.8 plus 1 by 3 of 3.2 over plus 32 into 4.5 into bracket 13 plus 4.5 divided by 2, that also over, plus half into 4.5 into 22 into bracket 13 plus 4.5 divided by 3 divided by 20. 202.0875 plus, see, plus 202.0875. Actually, slowly my speed in calculator is reducing because no much practice. Okay, that's okay. That's, you are youngsters, you can do fast. But still I can do fast only. Okay, then sigma V equal to 0. Check the answer. See, perfectly correct. I remove the entry. Sigma V 0, upward positive. You get plus VA plus VB, then minus this load, minus half into 4.8 into 45 is this load, again minus this load, only load now, no distance, into half into 3.2 into 45 minus this UDL, 32 into 4.5, again minus this triangle, half into 4.5 into 22 equal to 0. What you do? Substitute for whatever VB you got just now VB, substitute it. Therefore, you get the value of VA plus 171.4125 kilonewton. Okay, this is over. Now, make a note. Same as last time. We are in option 2. Just to understand. We took moment about A first. Sigma M about A0, then sigma V0. Some people will tell, sir, I want to take moment about B. Okay, done. In that case, you do not check the answer this way. Okay, answer over. Now, lastly, what you will do is, just to get fluency, not for checking. Remember, this is not for checking purpose. Not for checking purpose. In my class, no checking. You will imagine alternately, take moment about B. Then you will get VA first. Okay, now finger should be at B. Here, start. Plus VA into 20. I should not explain this one. Waste of time. VA into 20. Start. Minus moment of this load. half into 4.8 into 45 is the total load into moment about B. Its line of action is here. 2.5 plus 4.5 is 7. 7 plus 3 is 10. 10 plus 3.2 is 13.2 plus another 1 by 3. Not 2 by 3. See, this is 2 by 3. That is 1 by 3 of 4.8. Again minus moment of this load. Half into 3.2 into 45 into moment about B. 2.5 plus 4.5 is 7. 7 plus 3 is 10. 10 plus another from here to here. From here it is 2 by 3. 10 plus 2 by 3 of 3.2. Again minus moment of this UDL. How much UDL? See, this is the total load into distance. Total load into distance. 32 into 4.5 is the total load multiplied by 2.5. See, from B to this line of action. 2.5 plus 2.5 plus half of 4.5. 4.5 divided by 2. Again minus moment of the Y minus anti-clockwise about B. Half into that all already over. 4.5 into 22 is the total load multiplied by from here to this line. That is 2.5 plus from here to here is 2 by 3 of 4.5 equal to 0. You will first get the value of VA now. VA will come 171.4125. Some will tell, look at the calculator, sir. I will do whatever I want. You use the calculator. Don't tell me what I have to do. 4125 kilonewton. This is confidence. Okay, then. So I should not have removed sigma V. Sigma V0 upward positive. Same as last time. Okay, I removed it. So I write now. Plus VA plus VB. Just now explain. Why should I waste time? Minus half into 4.8 into 45. That is this load. Again minus half into 3.2 into 45. One more load. Minus 20, 30, 32. 32 minus 32 into 4.5 is the UDL. Again minus half into 4.5 into 22 equal to 0. Now you got VA already. Substitute for VA. Whatever you got VA, you will get VB equal to 202.0875 kilonewton over. Now we got the reaction perfectly over. Now what I will do is, I will close the class, but I will give you two examples for you, two questions for you. Two questions for you. What I will give two questions is, see, beam will be like this. Now this type of loading covered. Trapezium we covered only once, so just for practice purpose. One question I will give trapezoidal load this way. One more question, another question I will give trapezoidal load this way. So you can either take full trapezium, or if you divide like this and like this, you have to divide. Then along with that one, in one question I will put a point load here and UDL here. Another question I will put a point load here and UDL here. And I may give a couple also. That all I will give, systematically solve and get the answer. You have to be careful, carefully calculate. In the class I am not explaining anything. Just question, answer. Question, answer. But only in the notes, these steps I will give you. See, in the notes, I will give you little more information. But still I will tell them, refer to the class. Then only come to the notes. Okay, I will prepare it and then go to the class. Then next class you are changing over to other type of loading. Not other type of loading, we are changing the beam. Instead of simply support beam, we will go to overhanging beams. Two questions for you. Class, solve these two questions. Don't ignore. As you solve more and more questions, don't think time is wasted. Your grip will increase. Hope one fine day you'll be as fluent as me. Okay, now, direct answer given. Still, what I will do is, I won't use the pen. I won't use the pen. Maybe I will use the pen for writing something for my purpose. But I will tell steps. I will not explain anything. You write systematically. Where brackets are there, into means what, that all you have to decide, so that you can check your answer. I will tell fast. See, this question, I will take moment about A. First, trapezium as it is. Minus VB into, minus VB into 15 plus minus 180 plus 450 plus 30 plus 48 divided by 26 into 4 plus 30 plus twice of 48 divided by 30 plus 48 into 6 by 3 equal to 0. You get VB. Sigma V is 0. VA plus VB minus bracket 30 plus 48 divided by 2 into 6 equal to 0. You get VA. Or, suppose you go for division. This extra will be how much then? 18. Okay, sufficient. So, now, minus VB into 15 plus 450 minus 180 plus 30 into 6 into 4 plus 6 by 2 plus half into 6 into 18 into 2, 4 plus 2 by 3 of 6 equal to 0. You get the value of VB, sigma V 0, VA plus VB minus half, what it is? 30 into 6 minus half into 6 into 18 equal to 0. You get the value of VA. That's all. I did fast. See, I may be slow in calculation, but understanding I am not slow. Here, take moment about A. First, trapezium as it is. Minus VE into 10 plus 10 into 3 into 3 by 2 plus 100 into 9 plus 27 plus 12 divided by 2 into 5 into bracket 3 into bracket 3 plus 27 plus twice of 12 divided by 27 plus 12 into 5 by 3 equal to 0. You get the value of VB. VE. VB. This is V point, not E. VB. Sigma V0. VA plus VB minus 10 into 3 minus 100 minus 27 plus 12 divided by 2 into 5 equal to 0. You get the value of VA. Or, if you divide into parts, this is 12, this extra will become 15. Yes, then 10 into 3 into minus VB, take moment about here, minus VB into 10 plus 10 into 3 into 3 by 2 plus 100 into 9 plus where is it, 12. 12 into 5 into 5, 12 into 5 into bracket 3 plus 5 by 2 plus half into 5 into 15 into bracket 3 plus 1/3 of 5 equal to 0. You get the value of VB, sigma V0, VA plus VB minus 10 into 3 minus 100 minus, I have difficulty for reading the values, not for telling. 12 into 5 minus half into 5 into 15 equal to 0. You get the value of VA. Confidence counts. You go through slow speed, find one mistake. Work out these two questions. I did fast because it is completely for you. But still, when you write, if answer is not coming, you can listen to what I told and check the answer. Okay, we will meet in the next time. Next class, I am going for overhanging beam. Fresh starting, important, very, very important.